Yeah. Okay, so here we go. This is our second recording here. Let me zoom out to make sure that we have everybody can see. And I'm going to be doing problem number 13 of section 1.4. This is number 13. This is on your homework. Okay. It says h of x equals the natural log of x plus 1 here. Okay. So I need to find my extreme values. And my extreme values, if we recall, this is where f prime is equal to 0 and also where f prime does not exist. So the first thing we're going to do is I have to find where the derivative is. So I'm going to write this in steps. So step 1, I need to first find f prime of x. Okay? I'm going to first go ahead and find this one. And if I take the derivative, so this means h prime of x, I'm going to take the derivative. The derivative of ln of blah blah is 1 over blah blah times the derivative of my blah blah using the chain rule. The advantage here is that the derivative of this is just 1. So h prime of x equals 1 over x plus 1 times 1, which we all know is just 1 over x plus 1. Cool? And now what I'm going to do is I'm going to do step 2. The second step is once you take the derivative, you're going to set f prime of x equal to 0 and solve. Okay? So I know that h prime, or in this case, f prime is just h prime, and h prime is equal to 0, which implies that 1 over x plus 1 is equal to 0. And now we have something a little strange, right? You look at this, and if you try to pick numbers, you can't really find anything that makes this true. And you can verify this algebraically. So if I tried to solve this, if we remember, how do you cancel a denominator? You have to multiply by whatever is there, right? So let me just do that here. If I multiply by x plus 1 here. And we all know that x plus 1's cancel out, and I'm left with something that says that 1 equals anything times 0 is just 0. So I'm left with 1 equals 0, which is a contradiction. So thus here, this implies there is no value for which f prime equals 0. I just write f prime. That's the same thing as f of x. So if we go back to our original statement here, if we look back here, I tried to find this. There were no solutions for this because when I tried to solve for x, I got something false. So now I have to check, well, where does f prime not exist? Well, I have to look at f prime again. If we recall, the original problem was this one. This was h prime, right? So here, what value makes this not exist? And if you look at it here, well, what value makes this illegal? And we all know x cannot be what? Negative 1. Because if I put negative 1 in here, I get division by 0. So here, this implies that x equals negative 1 is a, and if we look here, that is where f prime does not exist, so it is an extreme value. So f prime equals negative 1 is a extreme value. And to check the height, we would plug negative 1 into the original function, which is here, but we're not doing that today. And this would be my final answer here. And we box this in here. Okay.